That humming noise you hear in the background is my fridge. And I need to be able to turn it off to make videos and yet be able to have it come back on automatically. So I put this little gadget together. If I push that button, it turns off. That flashing red light told me it was going to turn off for a very short time. Very soon it'll turn back on. If I push and hold the button, it'll stay off even longer. Now it's flashing about once every 2 seconds. That means it won't turn the fridge back on for about 2 hours. Now I just need to do something about the rest of the background noise. This is the code that controls my application that shuts down my refrigerator for a little while. I start off by defining some pin numbers. 13 is the pin attached to the blinking LED. 8 is the pin attached to the button. The button has a normally low input with a pull-down resistor, but when I push the button it goes high voltage. I've got a solid-state relay attached to pin 10, so that when pin 10 is high, that solid-state relay will turn on the power. And pin 11 is another pin that I'm going to pull high whenever I want the power to go off, even if I didn't push the button. I define a couple of variables here. Waiting is how long I'm going to wait before I turn things back on. So if I turn something off, I'll wait for waiting milliseconds until I turn it back on. I need to keep track of when I turned it off in the milliseconds time frame in order to know when I've gone for this number of milliseconds with it turned off. My setup does the things you'd usually expect. It starts up the serial port and sets the modes for the pins. The SSR is an output pin. That's something I'm going to control from the program. And these other two are the button is an input pin and the LED is an output pin. Then I get to my loop. So each time I go around, I set up the number which is the maximum time that I could possibly want to turn things off for. I'm setting it here to 8 times 60 times 60 times 1,000. 8 hours times 60 minutes times 60 seconds times 1,000 milliseconds per second. So that's 8 hours. The longest I could use there would be 24 days, which is half of the maximum time that millis cycles over in. Seconds per second, I'm setting that to 3,600, 60 times 60, so that when I push the button for 1 second, I'm actually going to add 1 hour of time to the remaining. So now I get to actually do something. If turned off is equal to 0, that means I haven't turned the thing off, and I haven't moved this external pin to high, then I'm going to set the SSR pin to high. That means that the power will always be on unless I've done something. Now, if the waiting value, the time that I should be waiting, is now greater than 0, that means I should be turning it off. So I'm going to set turned off to the current time in milliseconds, the time we're turning it off. And if that happens to return 0, which would be really unusual, I'll make it into 1, just to make sure that I have a non-zero result for turned off. If this wasn't the case, if the power wasn't supposed to be on, if turned off was already non-zero, then I would have written to digital output SSR with the value low, meaning turn off the power. Now that won't happen the first time I go through here. I'm going to set turned off to milliseconds, and it'll skip over and just go on down here through the rest. But as soon as it comes back to the top of the loop, about 10 milliseconds later, it's going to say, turned off isn't 0 anymore. And that's when the program flow will go down here and actually turn things off. So the timing is wrong by about 10 milliseconds, but I don't think that's something I'm going to notice in the real world. So now that I've done the actual control of the solid state relay, I'm going to check on the button. So if the button's pushed, and I haven't got the waiting time up over the maximum yet, then I'm going to increase the waiting time. If it's within the first 60,000 milliseconds, the first minute, I'm going to increase it slowly at about 1 second per time through the loop. After that, I'm going to increase it much more quickly so that I can go up with a 1 second button push to about an hour's worth of waiting time. I'll calculate now how much time is remaining. It'll either be 0, or if it's turned off, I can calculate remaining from the waiting time, the current time, and the time that we turn things off. If it's less than 0, then that means I should turn things back on again. So I'll switch turned off to 0. I'll switch waiting back to 0. And when I come around the loop again, turned off is going to be 0. And I'll turn things back on again. Now I'm going to provide some output to the real world, to me, that I can see about what's going on in the program. So this is where I'm going to blink the LED. And I'll set the blink rate equal to the time remaining divided by 3600. So that's going to blink faster when the time remaining is smaller. I'm then checking to see if I'm in the top half or the bottom half of a modulo calculation here. So if I'm in less than blink rates by 2 seconds, then I'm going to write it high. Otherwise, I'm going to write it low. So it'll blink things on and off. And finally, I'm going to serial print some debug information so that when I'm trying to make this work, I can figure out what's going on. Lastly, right down here, I'm going to delay for 10 milliseconds just to make sure that I only go around this loop about 100 times a second. I'm not particularly concerned about the exact timing. I'm not going to worry about it too much. I know it's not going to be perfect, but it's going to be about 100 hertz. So this code is all that I need in order to control my off switch for my fridge so that we can make videos without that background noise.